we can move on with the how to find the range. Is called the range, the interval, range or the interval, and the limits. And the limits within which the interval or the range, and the limits within which the true value of the expression lies. For the range or the interval within which the expression lies, it is defined as the minimum value, comma, the maximum value. So when you get the maximum value and the minimum value, then you can get the interval or the range within which the true value of the expression is expected to lie. And if the question is requiring for the limits, you state the limits, you state the lower limit. The lower limit is given as the minimum value, and the upper limit is given as the maximum value. So we can use an example, and we see how we can get the limits and the range. You calculate the maximum and the minimum value. Also the limits. The limits you state. The lower limit is the minimum value. The upper limit of the expression is the maximum value. So we can look at an example of how we can calculate. Here we are having the plot of lands has its width measured at 49.5 meters and its length 98.46 meters. So they want us to find the range. Let us find the range within which the true area of the plot lies. So when they want us to get the range or the interval within which the true area of the land is supposed to lie, first of all we need to know the definition of the area. In our solution here, the area A is defined as length times width. So the area it is an expression of two quantities, the length and the width. So to get the lower, first of all we need to get the lower limit and the upper limit, that is the maximum and the minimum value. Then we get the interval within which the true area is expected to lie. First of all, we have let us let the length be L, and it was given as 98.46. And we are looking at the number, since the errors which were made were not given, so we are looking at the maximum possible error, the maximum possible error, EL, can call it EL, since it has two decimal places, you count 1, 2, so it is 0.5 times 10 power negative 2, and this one here will be 0.005. That is the possible error which is made in that length. Then we let also the width BW, and this W was given as 49.5. So the width BW, and it is given as 49.5 meters. So the maximum possible error in the width, we can call it EW, and this has one decimal place to be 0.5 times 10 power negative 1, and this is 0.05. That is the maximum possible error which is made in the width. So what we do, we get the maximum area, and we can call it A max. And what we do from the definition area, since it is a product of the two quantities, we maximize. We get L max times W max, maximize both. So this one here will be area maximum, will give us the length. The length, it was given as 98.46 plus we are maximizing by each error, which is 0.005. Then times the width, we are maximizing the width, which is 49.5 plus its error, maximum possible error, which is 0.5. So when we use our calculators here, we can get the maximum possible error. So when you use the calculators here, we get the product of the maximum area and the maximum width. And when we use the calculator here, we are having the maximum area as 4878.94075. 4075. And this one here is in meters squared because the units we have given. And since the question has not specified the number of decimal places we should give you, they said maybe 2 decimal places, we will say 0.94, but we maximize the number of decimal places for accuracy purposes. Then we can also get the minimum area, and this one here we can minimize the length times you minimize the width, So here, minimizing the length, it is the value of the length, 98.4946 minus 0.0005 times minimize also and the width for the line 0.5 minus 0.05. Then we get the minimum area. So it is about maximizing and minimizing. After getting the maximum area and the minimum area, then you can get the interval. So you can use the calculator here. Use our calculator here to product of the minimum and the minimum here. Allow the minimum area 48685 8.5 9975, and this is a meter squared. So the range here we state the minimum value. We state the minimum value here, and the minimum value is 486.8.59975 meter squared. Then we state the maximum value 4878.94075. That's how we get the interval or the range within which the true value of the area in that plot is expected to lie. If they want the limits, then the limits will state the lower limit. You state it as the area, the lower limit. You state it as the area minimum. Then you state the value of the area minimum. Then the upper limit. You state the area maximum. Then you give the value of the area maximum if you wanted the limits. So we are having another example here. We are having two numbers. This is 4.0, 8.0, x is equal to 4.0, y is equal to 8.0. We are estimated with relative errors of 0.1 and 0.2. Respectively, find the limits within which the true values of x minus y. This is now our expression, x minus y is expected to lie. Now this time here we don't use that before as the one decimal place, then we use 0.5 times 10 to a negative 1, because that's what I just want to know, because the error has already been given that the x was estimated with the relative error of 0.1 and y was estimated with the relative error of 0.2. So what we do, we first get the maximum possible errors in x and get the maximum possible error in y. Then we get the limits within which the true value of the expression x minus y is expected to lie. So since they have given us the relative error, so by definition, the relative error is equal to the absolute error That is the maximum possible value in the number over the inexact value. Now those are the given values which are inexact, we are approximated. That is the relative error. So if we now look at we consider the x, so we are having the relative error in x is 0.1 is equal to the maximum possible error in x. So we can put the ex, the error in x, over the value of x, which is 4.0. So if we cross multiply, we shall have the error in x here as 0.40. That is the error, the maximum possible error, which was made in x if its relative error was 0.1. So we can also look at the next part of b, y, using the same definition of the relative error. So we have the relative error here was given as 0.2. So we are having 0.2 here is equal to the absolute error. So the absolute error, the maximum possible error in y, and divided by the inexact value. So we get the error which was made. Since you are given in the previous examples, we looked at where they have given the absolute errors and the percentage errors. Here we are looking at where you are being given the relative error and use the definition of the relative error. So here, this one here, when we cross multiply, we shall have the EY is equal to 0.1, 0.16. That is the maximum possible error which was made in y. So to get the maximum value is given as of x. It is x minus y. So what we do, we make x maximum, and what we are taking away, we make it very small. That is minimum. So how would we do that to get the x value, which is 4.0 plus its error, which is 0.40, then minus the minimizing this one, what we're taking away, so that we are making the maximum value, and y is 8.0 minus its error, which is 0.16. So if we use our calculator here, if we use maximizing the first, minimizing, because we want to make the maximum, so we have maximized the x and minimize the y. So when we use our calculator here, we are having negative 3.44 as the maximum value. Then we can do the same thing. We minimize, getting the minimum value there. If you have to get the minimum value, we are getting the minimum value. And the minimum value will be, since it is the difference of two quantities, x minus y. What you do is if you want to make something very small, you make this one very small, that is minimizing, minus what you are taking away, y, you make it very big. So meaning that here we shall have the 4.4 minus 0.40, that is the error in y. Then minus what you are taking away is 8.0, then plus the error which is 0.1, the error which is 0.16. So that is how minimize, make it very small, and what you are moving, make it very big, remain with a minimum value. So we can use the calculators there. So if we use our calculators here, this is the minimum value of x and maximum value of y. Then we have negative 4.56. When you look at these values, it should not confuse you. How comes that the maximum value is smaller? Negative 3 is bigger than negative 4 on the number line. So this one here, it is a maximum, is bigger than this one. So this is the maximum value, this is the minimum value. And since the question is calling us to get the limits, so we come and state the limits, the upper, the lower limit. The lower limit is you state the lower boundary, which is negative 4.56. Then the upper limit, you state the maximum value, the upper boundary, which is negative 3.44. And that's how you state the limits. If you state it in the brackets, this is an interval, or it is a range within which the true value of the expression is expected to lie.